Hi, it's Lee from the Japanese Water Gardens. This week's video is a step-by-step guide to building your very own blockwork koi pond. I'm going to be going through the entire process, including the design and planning stage, excavation, construction, waterproofing options, pipework, pumps and filtration. Along the way I have several big tips that I believe can make all the difference between a successful and enjoyable pond and one that quickly becomes a chore. I will also be pointing out some of the common mistakes that people make so you can hopefully avoid them. The construction methods that are detailed here are for a concrete box pond with a bottom drain and gravity fed filtration system, but there is a huge amount of information relating to ponds in general, so there should be something of interest for everyone, whether you're new to koi and considering building your first pond, or you're a seasoned koi aficionado. Okay, so make yourself a coffee, take a seat and let's get into it. We've all heard the saying, fail to plan, plan to fail. But that's exactly what most of us do when it comes to ponds. We rush into the construction stage with little or no consideration to exactly what it is we are trying to achieve. Suddenly, we realise that the pond is too big and there's no room for a proper filter. Or we can't afford to buy a quality liner, so we install a cheap PVC one and soon it develops a leak. So, straight in with a big tip for success. Make yourself a plan. The plan should include some drawings with dimensions, an estimate for materials and a task schedule. Before you get started though, get out into your garden and decide exactly where you're going to put it. I personally like to see a pond built close to the property whenever possible. The reasons for this are simple. You generally have easy access to power, water and drainage, and being able to enjoy the pond from your living room or kitchen whenever you want to is really nice. Avoid areas with overhanging trees that will drop a lot of leaves in autumn. Having said that, some shade for the pond is not a bad thing, particularly if your garden is south facing. Shade helps to keep the water cooler in summer and it reduces the growth of the dreaded blanket weed and green water problems. Don't forget, you're going to need some room to accommodate a suitable filter system. One of the common mistakes that people make is to try and hide this thing away in some obscure part of the garden, perhaps at the back of a shed or in a garage. Now, more often than not, this is simply more trouble than it's worth. If this system is going to be installed gravity fed, which we would certainly recommend, you may end up needing to dig up the floor of the garage, for instance. That is a huge amount of work that you simply don't need to do. The most logical place to accommodate the filter, in most cases, is right alongside the pond. When you've found a suitable position for the pond, get out the tape measure and just see how much space is actually available. That will give you a good place to start with your drawings. These drawings don't have to be anything fancy. In fact, my boss and mentor, Bernard Channing, is famous for what he calls fag packet sketches. Simple plans that he scribbles down on the backside of a fag packet. Now, sometimes this is all you need, but I recommend that you try and show a bit more detail in your plan. Try and work to a rough scale. Show some basic dimensions. Draw in the position of the bottom drain, the skimmer, the pipework, and show where this all-important filtration system is going to go. You need room for the pump, the UV, and so on. Draw in as much of the pipework as you can. A lot of discussion is made on pond size. Now I want to say straight away that there is no minimum size for a koi pond. Having said that, a lot of people end up extending ponds later, so it's a good idea just to go as big as you can right from the start. A rule of thumb is to get at least 4 feet of water depth, and the fish will always enjoy the freedom that a large dimensioned pond can offer. If you go deeper than about 5 or 6 feet though, things can get very difficult. I once attempted to refit a loose bottom drain cover in a 9 feet deep pond and it was almost impossible. Avoid complex shapes, ponds with too much fussy contours, stick to either a rectangle or a kidney shape. This ensures good flow, and you'll probably have no planting, so shelves are a waste of time. Don't be afraid to try several designs until you finally commit. You might want to use a computer program such as Adobe Illustrator or Corel Draw. Both are very capable of producing top-down plans and profile drawings. If you want to progress into 3D, then I can highly recommend SketchUp. It's free, very powerful, and once you've mastered the basics, it's really simple to use. The graphics in this video were mostly created in SketchUp, and YouTube has got a lot of tutorials that can get you started. Once you've got your drawing, you can start to prepare a list of building materials, pipework estimates, pumps, filtration hardware, etc. Include in this list an allowance for waste removal and any equipment hire that you may have. If you can complete the work yourself, then great. If not, you might need a builder, a labourer, an electrician, whatever. Then all this needs to be put down on your list as well. If you already have a pond full of koi, then you may need some kind of temporary holding facility. Everything that you put on this list is going to help you to get your budget right. From experience, I have to say that few, if any, ponds actually come in on budget. Most end up costing a lot more and taking a lot longer than expected. So there's a lot to think about in the beginning. Decide exactly where you're heading with this before you proceed into construction. The planning stage is definitely not to be rushed, and it can actually be a very rewarding exercise in its own right. The first part of construction is to prepare the ground. Basically, this involves clearing the site of rubbish, any obstructions, any vegetation. What we're trying to do is create enough space to accommodate the materials and equipment. It's amazing just how much space you're going to need. Being organised and professional will make the whole process run much more smoothly. Refer to your plans, take a peg and line and mark down the footprint of the pond onto the ground. Don't forget about this filtration system. As you can see, we've added an extra line on this drawing here to indicate that. Before you start any excavation, make sure that you're entirely happy with the dimensions and shape of the pond. If this is the first time that you've had a real feel for the scale of the thing, you may want to make some changes. If so, get straight back into your plans. Now, this is the real hard part, the digging out. This pond is going to be raised down to the ground by 30 inches and it's going to be 5 foot deep, so we're going to need to remove about 3.5 feet of earth. Depending on the type of ground conditions that you encounter and your level of physical fitness, you're either in for a huge amount of pipe breaking effort or worse. Digging out tons of soil and clay and rock is absolutely exhausting. It really is literally back-breaking. If the weather is wet, it's going to be messy and sticky. If it's hot, then you're going to run the risk of developing heat stroke. So take your time. If you can use some kind of mechanical excavator, then do so. Some of these modern compact machines are capable of slipping between some very tight gaps. Having a machine like this can save you weeks of true back-breaking toil. And sometimes, the cost of them is well worth it. You can even hire these things sometimes with a driver. I believe the cost per day is something like 150 quid. It's well worth it if you can use a machine like this. The other thing that's very useful to have is a mechanical skip loader. If the machines are not an option, then list the help of a labourer and pace yourself. Don't push things too hard. After all, you've not got anything to prove. As you progress, keep referring back to your plan. Here you can see that we've dug down 2 levels. One of them is for the pond and the other is for the filtration. The extra part that we've dug out in the corner is where the bottom drain pipe is going to pop up. The next stage is to lay down a layer of compacted stone, which is referred to as a hardcore base. This base gives you a level foundation to support the weight of the walls and the concrete. The depth of this base is not super critical. Normally it's done to 3 or 4 inches, but the important thing is that it's got to be compacted down properly. Ideally you would use some kind of powered whacker plate or a manual device that you can use to pound the stone. This stage can be omitted completely sometimes if the ground conditions are heavy clay or stone and there's no chance of any movement or settling occurring. If so, then you can just build basically straight up off the earth. However, if you're at all unsure or you're planning on waterproofing this pond using paint, then don't miss this out. Right, here comes big tip for success number 2, and this really is a big one. Fit a bottom drain. Without doubt, this is the single biggest step in the right direction that you can make. Now, I'm not going to say to you that nobody ever built a successful koi pond without a bottom drain, because that's not true. But make no mistake, the extra effort and expenditure is more than justified when you appreciate the difference that this can make to the system. You may wish to use one of the aerated drains, that's entirely up to you. This one though, for the purpose of my exercise, is just a basic design. The bottom drain is a connection between the pond and the filtration system. It is positioned in the middle of the pond at the lowest point, and it is very efficient at pulling in the solids and transporting them through into the filter system, where a pump will then return the water back to the pond. The alternative to a bottom drain system is to place the pump in the pond and run a pipe out to a filter which is positioned on a higher water level, and then the water will run back through gravity. This alternative method is not ideal. Often pumps chew up solids and they make the job of the filtration a lot more difficult. Pumps that have got attached cables and hoses look unsightly, and they trap sediment and they pose a potential threat to the koi and the koi keeper. You could electrocute yourself on the pump, or the koi could scratch themselves against it. Don't worry about the sealing process of the drain onto a rubber liner. It is really simple. I've heard of many people being put off installing a bottom drain just because they're a little bit worried about creating this seal. Well, believe me, it's not a problem at all, and when we get to it, I'll explain it. As you can see, the drain is simply placed flat on the hardcore base in the center of the pond, and we take a level from the drain flange, and at the edge of the pond just knock in a few wooden pegs that will form a level. This will serve as a guide when we're casting the concrete. We then attach a length of pipe to the drain, run it across the bottom of the pond where it turns through 90 degrees, and a short piece of pipe is attached that we cut off at the correct length later. Do not glue anything at this stage, just join them up dry and use a black marker to indicate where they join up. The pipe that you're using for this should be 4-inch or 110mm solvent weld pipe. It doesn't necessarily have to be pressure pipe. Standard poly pipe is more than adequate. The best way to cut this pipe is just to use a handsaw. Remove any burrs on the ends of the pipe with a bit of sandpaper or a file. Give them a good wipe down with some pipe cleaner. This prepares them to take the glue, and it softens the pipe up, and it also cleans the end of the pipe up. When you glue it, make sure that you don't skimp on this glue. Smear it evenly on both the pipe and the fitting and push it together, making sure that it goes all the way home and you line up your marks again. You'll notice that this second piece of pipe has been put in as well, that's going to serve as a return to our pond from our filter. This pipe could also be run around the perimeter of the pond after it's built, but by putting it straight across the bottom like this, it means that we're going the most direct route and we can save on a few pipe fittings. And the pipe that we're going to use for that is 1.5 inch solvent weld pressure pipe. Right, now we're putting in some spacers that are going to be used to support the reinforcing base, the wire meshing that we're putting in to provide additional strength. You keep this mesh off the floor with any kind of spacer really. It could be bricks or plastic things that are made for the job. Whatever you use, just spread them out evenly across the base. Then we lay wire meshing on top of the supports, and we use cable ties or bits of string to hold it firmly in place so nothing moves when we start to concrete. Rebar is then attached to the meshing and it's held firmly with cable ties. The rebar is bent upwards at 90-degree angles from the base. We're going to use 3 or perhaps 4 rebar sections down each side, depending on the length. It's worth mentioning that the mesh and rebar can be omitted if your ground conditions are good and there's no chance of any movement again. But if you're at all unsure or you're planning on waterproofing it with paint, then I strongly recommend that you include them. Here comes our concrete slab. It's laid down to form a base from which we're going to build the walls. The thickness of this base will be about 4 or 5 inches, and the concrete will finish level with the flange on the bottom drain. Normally a mixture of 5 parts ballast to 1 part cement is fine if it's mixed properly. The mixture should be made quite sloppy so that it's easy to level out with a rake or spade. It's likely that the bottom drain and the pipe are going to try and float up. To prevent this, you can either fill it with water or chuck some bricks in the bottom of it. Stuff a plastic bag in the pipe so no debris gets in there. The base that you're creating of this size is a very big job, and even with a cement mixer it's going to be hard work. If you attempted to mix this quantity by hand, it really would be soul destroying. It might make a lot of sense to have this delivered as a load and just barrow it straight into the hole. If it's a very large base, then you might even be able to get it pumped in. Make sure that you tamp and level out the concrete. Use your wooden pegs as guides. If you can float a smooth finish onto it as it's setting, then this is going to remove the need for any further rendering of the base. And on a very large pond, I would consider actually hiring a vibrating plate. The concrete should be covered over with a tarpaulin or a plastic sheet and left to cure for a couple of days. Right, we're now moving on into the building of the walls of the pond. They're going to be made from 18 by 9 inch hollow blocks. It is normal first to construct the corners and lay a string line down. The blocks should be dropped down over the rebar and bedded onto a well mixed mortar of 3 parts sand to 1 part cement. It's worthwhile using brick ties as well to give it further strength. And as you build up each layer, you can fill the voids with concrete. Building with blocks like these is not as difficult as you might imagine. There are some great videos on YouTube that can help you perfect your block laying technique. With some practice, even a novice can achieve passable results. It's important that the walls are level and that they're straight. Any defects are going to be really noticeable when the water goes in. So if you can't do a decent job, then get the help of a builder. Don't worry too much about the pointing up on the outside of the mortar though, as we're going to render this surface anyway. Okay, now we've built up the pond walls to the required level and we're preparing to fit a surface skimmer. So we leave out a couple of blocks like you see here. Now I won't pretend that the surface skimmer is as important as the bottom drain, but I would strongly recommend it. It's a good feature to have, and trying to retrofit one is very difficult. The free floating ones that you'll see on sale are never as effective and they can look very unsightly. When you set up a skimmer properly, It will collect any surface debris such as leaves or uneaten food. It's also very good at preventing the hazy sheen or protein layer that you can see forming on some ponds. It makes the water look polished and it shines. You don't need anything fancy with surface skimmers, absolutely no point at all. A standard in-wall pool skimmer is perfectly adequate. They're the same skimmers that you're going to see in use in swimming pools. Then they have a little self-adjusting weir plate inside which just floats below the surface of the water, and as you're drawing in the water it just skims the top water into a little basket where it collects the debris. The key to making a skimmer work well is to get its position correct in the pond. Now this is correct in relation to where the water returns and the right elevation in the wall. I'm going to show you a picture now of where this is wrong. What's happened here is that the skimmer has been put too low in the wall, and that's led to them not being able to properly fill the pond up to the top. The top of the skimmer should actually protrude above the top of the blockwork. It's easy to get this right. Just draw a line on your blockwork where the water level is going to be when the pond is completely full. Then set the skimmer so that the water will be 2/3 of the way up the opening. When the final blocks are set, they will lock the skimmer into place, and any gaps can be filled either with mortar or small pieces of brick. You should leave a small section of pipe sticking out the back so that you can connect onto it later with the pump. The next step is to render the inside of the pond surface. For this we use a mixture of 3 parts sand to 1 part cement. There are some additives that you might want to use to improve the strength of this render. A plasticizer can be used to improve its workability. Sometimes PVA glue is added to help it stick better. Glass fibre reinforcings are also commonly used, but I personally don't believe that this is needed unless it is your intention on waterproofing the pond with paint. If you are painting this pond, then don't use any waterproofing compounds in the render. They apparently prevent the paint from properly keying. The render should be applied to a thickness of about 5mm or so, and it can be used to round the edges off inside the pond if you feel so inclined, although I doubt really that there's much to be gained by doing that. If the base is nice and smooth, then don't bother rendering that, as there's little or nothing going to be gained in doing so. The render should be smoothed over to provide a nice surface. If you have used glass fibres, then burn off any that are exposed and rub over the render with some sandpaper. Don't leave any sharp edges. Make sure that the pond is covered whilst the render is drying. Rendering can actually be a bit tricky, so this might be something where you decide to bring in a professional. I wouldn't bother about rendering it at all if you're going to waterproof it with a rubber liner. And an alternative to rendering the pond that seems to be becoming popular at the moment is to line it with polystyrene sheeting. The theory of this is that it insulates the pond. Whether this is worthwhile or not, I guess it's open to debate. Also, obviously you can't paint onto that kind of sheeting, so if it's going to be painted it has to be rendered. Right, now we're moving on to the waterproofing of the pond, and we have 3 main options when it comes to waterproofing a pond. The main options are an off-the-roll rubber liner, bespoke welded liner, waterproofing it with some kind of paint, or using what we call GRP fiberglassing. I'll spend a few minutes and discuss the pros and cons of each. First up is the classic off-the-shelf rubber liner. Now this is a great choice if you're on a budget and you want something that's easy to do a DIY fit. You can join it easily to a bottom drain and a skimmer by using the provided screws and flanges, and silicone should be used to form a waterproof gasket. The rubber liner will provide you many years of service. The only downside really is that you're going to have some folds and creases that can look unsightly, and they can trap the solids. Having said that, with some care, the folds can be pushed into the corners. If you've got shelves in this pond, then I would definitely not recommend a liner, as the folds and creases just become unavoidable. I'd also recommend that you use some kind of underlay to protect the liner. Do not use a cheap PVC liner. It will definitely lack the durability and flexibility of a rubber one. Avoid the laminated liners too. They have like a weave running through one side of them, and they are no good. It's really got to be rubber or nothing. You can also get what we call a box welded liner that is manufactured to fit your pond, provided it's a simple shape. They're cut out and seam welded in a factory, so the folds and creases are not a problem. They're also cheaper than fiberglass. Durability with them is not a problem, and they are sealed onto the bottom drain as before. The downside to the box welds is that they can end up becoming virtually as expensive as fiberglass, and they're not as practical to make if you've got a pond with contours. Waterproofing paint is cheap and it's easy to apply, and you don't get the issues with the folds or creases. It's possible to do a good job with pond paint, but I've got some reservations about it. Unlike other options, paint is entirely dependent on the surface to which it's applied. It adds nothing to the structural integrity of the pond. If any cracks ever develop in the render, then it's going to fail. If you build the pond to a very high specification and you can guarantee that there's not going to be any movement or settling, then it'll probably be okay. But to do that, you may as well go to the next level, which is fiberglass. Fiberglass is the ultimate waterproofing material for a pond. This is where sheets of glass matting are laid up on the walls and wet out with resin, and they're finished with a waterproof layer which is referred to as a flow coat. You can choose any colour you want. Personally, I like green or black. If this is done to a high standard, this finish will look perfect and it will last a lifetime. It is super strong. Even if cracks develop on the walls, the render, or even if the render falls off, it's still gonna hold water. Fiberglass can be expensive though, and most people end up enlisting the help of a professional to apply it, as it can be tricky. If your budget allows it, go for it. It really is the highest quality finish possible. One word of caution here though is to be cautious of anybody offering this service at a discounted price. Often they use substandard materials and they do a poor job. You need to look for some references. I can recommend NKB. Stuart Borman does a good job. He works out in Nottingham. If I remember, I'll leave his number at the end of this video for you to take down. Right, we're moving on now. At the side of the pond, we're going to be building a filter chamber, so we need another layer of hardcore that we again pound down properly as before. 3 or 4 inches deep should be fine, so long as it's properly compacted. Third tip for success is to install a good drainage system for your pond. This is something that is very important that you get right. As part of your regular maintenance, you're going to need to discharge dirty water away to waste. This water can be quite dirty. It's not going to contain a lot of solids though. Now, as you raise the pond off the ground, you're going to greatly improve your options as to where you can run that water to. The first and best option for this water is to run it into an existing rain or foul water drain. Now there is some debate as to the legality of doing this, but I've never heard of anyone being pursued over such a matter. If you've got a suitable drain, then I would pipe into it. Your second option is to discharge the water into some kind of natural soakaway. This could be a large planted border, for instance. The water from these ponds is excellent for watering plants. This method is often very cheap and it's easy to do. If you've got a big enough area to accommodate the water without flooding out your neighbours, then this might be the way to go. The third option is to construct a sump which will serve as a soakaway. The sump will need to be of a sizable capacity, let's say 100 gallons or so, and again it's going to need to be lower than the discharge points. You can install a sump pump into this with a float switch on it that will pump away the water to waste. This method will involve some effort and expense, but it may be the only option available to you. In some situations, water can just be discharged directly out of the filters and allowed to soak away. But I've seen many systems like this end up thinking, like a dead pig and crawling with flies. Find a good solution to this problem. Put in some extra effort into the pond and avoid the stress and hassle later. You're soon going to get tired of running backwards and forwards to your drain with buckets full of dirty water. On this pond, we're going to be installing a standard section of drainage, which is in the concrete base, and we're going to connect our filters into this. The added benefit of doing this is that it will prevent any water building up around the chambers or around the pumps and pipework and so on. Right, now we're moving on to actually casting the concrete base for the filters. The height of this base is determined by the height of your filtration system. Normally the concrete will be around 4 or 5 inches thick. Again, it's going to need to be tamped down level with the top of this drainage section. The finish on this base is not critical. In comes our filtration system. Now this is a simple bay filter that comprises of a settling chamber followed by some brushes for mechanical filtration and then some matting for biological filtration. I'm not going to go into a lot of discussion over the different types of filtration. That goes way beyond the purpose of this video. Hopefully at some stage in the not too distant future I'll be able to get a video done on such a subject. Hopefully we'll get round to doing that one soon. So the important thing that I want you to note from this filter is that it is standing level with the water in the pond, and that this is what we refer to as a gravity fed system. For some reason people seem to find this a little bit confusing, but it's actually really simple. To connect the filter to the pond, we'll cut off the 110mm pipe, glue on a 90-degree bend, and install a suitable valve. The valve is needed so that you can hold back the pond whilst you're draining the filters. The best option, if you can afford it, is a ball valve, as is shown here. They never fail, but they are expensive and bulky, so gate valves often get used instead. It's up to you, both will do the job. Right, here we go, starting connecting up this 1.5-inch pipe work. We need to use decent quality 1.5-inch solvent weld pipe for this job. It is grey in colour, it is reasonably priced, and there is a huge range of fittings available. You might consider using what I call 43mm solvent weld domestic pipe, but it's not as durable and the fittings that you get are limited. Under no circumstances should you be using PVC flexible piping. It's very prone to becoming brittle, and it serves as a major flow restrictor as it's joined by an internal sleeving system. The so-called rubber boot fittings can also be used if you want to, but they are expensive, so I tend to only use them when it's awkward to use solvent fittings. The solvent pipe should be measured out to length, cut, then sanded or filed back. Set everything up dry first with no glue. When you're happy, use your black marker again to indicate how the pipework is joined. clean all the ends and fittings up with the pipe cleaner fluid before you apply the glue. And again, use a generous coating of the glue on both the pipe and the fitting that you're going to join. Push everything all the way home and make sure that all your pipe marks are lining up. We need to connect the filtration outlet into the pump and then run a pipe back to the pond. On the way, it's going to pass through the UV system. Note how the skimmer line is teed into the pump. This allows us to balance the water flow from the filter and the skimmer. I will point out a common mistake that I see people making with skimmers. They connect the pipe from the skimmer into the filtration system or the bottom tray. You really don't need to do this. It's going to achieve nothing. It reduces the amount of water going through the bottom drain and it reduces the efficiency of the bottom drain. You also get a very poor pull on the skimmer when you do it this way. My way is better, so just do it this way. Right, here comes another big tip for success, and it is that you should use demountable couplings. Whenever an appliance is installed, it is a good idea to fit demountable couplings. You also call these brake unions. They allow you to release a piece of equipment from the pipework quickly and easily without having to resort to getting a saw and cutting everything up. You can be certain that sooner or later something will block up, something will break, or something's going to become airlocked and you're going to need to get out a pump or a UV. In such a case, fittings like this are an absolute godsend. Ball valves should be installed either side so that you can hold the pond water back without the need to drain the pond down. A lot of people are very surprised at the pumps I choose to use. They are actually submersible pumps that have been stripped from their casings and dry mounted onto the pipework. Use threaded brake unions and PTFE tape. Very simple to do, very cheap, very reliable. The Oaza Aquamax and its spin-offs are the ones that I am referring to. These pumps will be running 24 hours a day, so they need to be efficient. Nobody wants a big electric bill. The compromise you make with these pumps over, let's say, a swimming pool pump is they don't have a lot of oomph. You get a good flow from them, provided you aren't pushing the water up more than a few feet or so, and the pipework isn't too restrictive, which it won't be if you're using the 1.5" stuff that I recommended. Anything such as a UV filter or inline heater should be mounted on a suitable wall. Often they will come provided with brackets. Spend some time and decide where is going to be the most appropriate position, and don't install it where it will be difficult to get at. You would be amazed at how many times I've gone to service a UV on a customer's pond and I've been unable to remove the bulb because there simply wasn't enough clearance. Sometimes the simplest jobs become a nightmare. The bulbs in these things emit UV light that prevent green water algae. They should be replaced at least once every 12 months, even if they appear to be working, as the UV light output will decrease to next to nothing. The drainage from the filter system is connected to the drain. Notice that there are ball valves so you can drain each section of the filter independently. I strongly recommend the use of ball valves here, as slide valves will quickly develop small leaks because of trapped solids getting caught up in the seals. Slide valves are slightly cheaper and take up less room, but they are not as reliable as the ball valves. To get the water into the drain, you can simply cut through the grating with a grinder and fit a 90-degree bend as I've shown here. This works very well. I also don't bother gluing the pipes going into the drain, as it is quite common for them to get blocked with clumps of dead blanket weed or leaves. By leaving them just push fit, you can break them apart and clear such a blockage quite quickly. Yes, you do get some water leaking from them, but it is very minimal. And of course, This only occurs when you're actually in the process of draining down the filter system. When returning water to the pond, I like to install eyeball fittings. This is a fitting that you will see in a swimming pool, and it has a small ball inside it that can be swiveled around to alter the direction of water flow. It should be positioned on the wall opposite the skimmer and then angled upwards, pushing the surface water into the mouth of the skimmer. Set up in this way, the skimmer will virtually swallow up all the surface material, and it works like a dream. The fish also seem to enjoy swimming against the flow, and it helps to keep them exercised. To install it, drill through the blockwork with a diamond core drill. Push the eyeball back against the wall and secure it with a pair of screws and plugs. A waterproof gasket can be formed by applying a generous bead of aquarium silicone. If you prefer to return the water down a waterfall or over a rill, then you could always tee off and split the return. Large ponds with a high flow rate will benefit from more than one return. On a well-made pond, the plumbing should all be hidden out of sight. A nice little trick that you can use to hide the return pipe is to recess it in the blockwork. Cut this channel out of the blockwork with a still saw or grinder, then break out the stone with a bolster chisel and lump hammer. This also protects the pipework from accidental damage. Not hard to do if you go about things in the right order, and the result will look very professional. Now all the main pipework and filtration is in place, we can block it in. Sometimes it would be preferable to build this wall first, but by doing it now, we don't have to keep hopping over the wall to grab a pipe fitting or whatever. It just makes things easier. The blockwork is done in exactly the same way as the rest of the pond. The pond is going to need a 240 volt 13 amp electric supply. If you want to comply with regulation, then it should be connected directly to your main consumer unit. It should have its own switch on the unit and be run out either through a conduit or through armoured cabling. It should be RCD protected. However, in practice, it is very common for this supply to be taken as a spare from a nearby shed or garage. I am not a big fan of the little switch boxes that get used on a lot of ponds. They are fiddly things that are hard to wire up in a confined space. Half the time, you don't know whether an appliance is on or off, and they tend to break after a very short period of time anyway. My recommendation is for a large, weatherproof box with plug sockets. Very easy to access, and you can fit an isolator switch to kill all the power if you want to, or switch off each and every appliance separately. You will need at least 4 sockets, better off though with 6. If you're fitting an electric heater to the pond, make sure enough load is available. Anything over 3 kilowatt could cause you problems. Over the years, I have encountered so many badly installed power arrangements, and quite frankly, a lot of them are hazardous. If you're not competent with electrics, then do get a pro in. Right, here comes another big tip for success. Fit an auto top-up. This one might seem like it's more trouble than it's worth, but it's actually a very simple accessory to fit, and they're also very cheap. And imagine just how much time this one could save you. You've just done a flush on the filters, so you're going to need water to top the pond back up. So out comes the hose. You turn on the tap, stand there watching it for 10 minutes, then get bored. Half an hour later you remember about the pond, only to find that it's now overfilled with water, and you have to discharge more to waste in an attempt to correct the problem. Then you've still got the job of rolling back up the hose onto a spool, or more likely you'll just leave it out because it's a hassle putting it away. This really is nuts. But this situation is the same situation that you're going to find yourself in every week. So just spend a few extra hours in the beginning, locate a water supply, run a pipe out to the pond, and fit a ball cock. Now, whenever a water change is needed, No problem, just let the ballcock restore the water to the perfect water level while you sit back and enjoy a cup of tea. The ballcock can be fitted to a gravity-fed system, as it's shown here, or if this is not an option, then a chamber can be mounted on the wall alongside the pond to serve as a balance tank. If you're worried about contaminating your pond water with chlorine, then install an inline dechlorinator unit like the one in the corner here. The water supplied to the ballcock should have an isolator tap fitted. This allows you to switch off the water whilst you're draining the filters. We need to finish off the top of this pond with some cappings. If you're fitting a liner, then this needs to have been done at the same time, as it holds down the liner. Whatever you choose for this should be sufficiently heavy and mortared down with a good mix. You don't want them working loose over time and wobbling about, as they so often do. The media for our simple filter is a chamber of brushes for mechanical filtration, followed by a chamber of Japanese matting for biological filtration. Very basic, very traditional, but this kind of filter does work well. Hopefully we'll discuss filtration options in a bit more detail in a future video. To finish off the chamber, we are going to cover it with some wooden deck boards. So a length of angled iron is screwed and plugged to the blockwork to form support. Now, yeah, you could do this with a wooden batten, but even if it's treated timber, I've found that they rot quickly, so the iron is a much better choice for this job. The filters can be covered now with some type of decking or boarding. Some people worry about using pressure treated timber, but I've never known anyone having an issue with it. Although it wouldn't be a bad idea to let the timber weather for a week or two prior to placing it over your filter. Take care not to use boards that are too heavy or tightly fitted. If you're going to make something that's on a hinge, then do it in manageable sections. When these things get wet, it's surprising how heavy they can become. If they expand, they may get trapped in the frame. You're going to need to access these filters weekly, so let's make sure that it's an easy process. I have chosen to finish this pond with a nice clean render. There are other options, of course. You could run up a facing brick, maybe clad the pond in timber, but this render is cheap to do, and if it is done well, then it looks great. A simple render can be made up from 3 parts sand to 1 part cement, but there are ready-mixed rendering mixers that have waterproofing compound and colours built into them that are a very good choice as well. The render will completely hide the return pipe work, giving a very good quality professional finish. To ready the pond for fish, give the walls a good wash down and flush away any debris from the bottom drain. All that now remains is for you to fill up the pond with water and let it cycle for a few days before you introduce your koi. Don't stock up your pond too quickly. It takes months for a pond such as this to fully naturalise. If you have some media from an existing pond, you can transplant it into the filter and it will help the bacteria establish more quickly in your new filter. There are some treatments that can also help with this process. Be watchful of the water conditions, namely the ammonia and the nitrite in the first few weeks. Extra water changes are always worth doing. Thank you for watching this video. I hope that you enjoyed it. If you would like to see more, then please like and subscribe. Until the next time, take care and happy pond building.